Okay, good morning to all of you. In this class, we are going to discuss about transformation of 2D random variable. In our last class, we have been discussed five numericals based upon one-dimensional transformation of random variable. This one and this one, third, fourth, and fifth. And one question I given to you that you have to do by yourself. I hope you all have been done this one. Okay. So now we are going to start the transformation of two-dimensional random variable. Okay. So let's start. In this section, we will discuss on change of variables in two-dimensional case. Now let us consider two random variables x and y are to be transformed to random variables are to be transformed to the random variables to the another two random variables that u and v by the transformation, that is your u equal to uxy and v equal to vxy. Here v and u both are function of x and y, where u and v are continuously differentiable functions for which Jacobian of transformation is this one. J is the Jacobian, that is your del xy by del uv, where here xy are transformed to another two variables, that is your u and v. So each and every values of x y, so these x small x and small y represents the values of random variable x and y. Okay, all the values of x, all the values of y are to be transformed to u and v by using your Jacobian transformation, this one. Okay, so del x by del u, del x by del v, del y by del u, del y by del v are determinant that we know, and the j is either 0 greater than 0 or less than 0 throughout the xy plane, or uh, you can say in the set of xy points. Okay, now we have to go for a theorem that the joint pdf, that is your f of u v function of u v of the transformed variables u and v is equal to this one, where j mod is the modulus value of the Jacobian of the transformation of fxy is expressed in term of u and v. So this one we are going to be prove. See, these things already we have been proved in case of one dimensional case. Okay, may you remember that this one we have been proved, that is your y, here x is transformed to y, that is a pdf of y will be equal to pdf of x into dx by dy. This is one dimensional Jacobian, and here this j modulus is the two dimensional Jacobian, right? So now, according to conservation of probability, we know that if probability of x which varies in between x to x plus dx, y varies from y to y plus dy, that has to equal probability of uv, where u varies in between u to u plus du, and v varies in between the limit v and v plus dv. Or you can say that uh, see, here we are going to consider xy plane. This is your x, suppose y, and we are going to consider a small so x, this is your x and this is your x plus dx, and suppose we have to consider that this is belongs to y and this is your y plus dy. In between this we have been taken the range region where we have to find out the probability in your xy plane or the variables of the random variable random variables x and y. But when the x and y is transformed to u v, that means all the x values are transformed to u, all the y values are transformed to v. So whatever the each and every point of inside this area has to be transformed to the area in between u plus du and v plus dv. So if we are going to consider the probability inside this area, that has to be equal to this one, okay, according to conservation of probability, whatever written over here. So that implies this is nothing but your probability density function into the small area. Here this is the length of dx and this is the length of dy. The area is nothing but dx into dy. So this is your pdf in the case of xy random variable or xy plane, and this is the area. So total probability of this area or inside this area has to be equal to the total probability inside this area. So total probability of this area will be probability density function having uv are the random variables into du into dv. Let this is your equation number 1. Now consider transformation coordinate or variable. Now consider transformation of coordinate or variable with the help of Jacobian. Here u and v are the transformed variables from x and y. Hence the area element dx into dy, this is the area element, will be written as we discussed previously. This will be this dx dy is transformed. That means xy is transformed to uv. So the area element will be written as Jacobian into du into dv. That things already we have been discussed previously. So the equation number 1 here, it can be written as, instead of dx dy we have to write j into du dv. So the equation number 1 will be f of uv into du dv. Here f uv density function, probability density function in uv plane into du dv is equal to this one. Here d, instead of dx we have to write j into du into dv. This is your dv, mistakenly written, this is your dv, okay, dv, right? So here du dv got cancel. In general we can write here pdf of uv equal to pdf, probability density function, in xy plane or two random variables xy, or you can say joint pdf of uv equal to joint pdf of xy into modulus of Jacobian, because as we discussed here that j either be greater than or less than 0. So in general we have been considered modulus of j, which helps to transform xy coordinate to uv coordinate or xy variable to uv random variable, okay. So hence it is proved. This is useful to solve the numericals, okay. Now we are going to go for the another theorem, that if suppose x and y are two independent continuous random variables, then marginal, this is a marginal, MARGINAL, marginal pdf, marginal probability density function of u equal to x plus y is given by f of u equal to minus infinity to plus infinity pdf of v into pdf of y u minus v into dv. If it is independent, if y and x and y are the independent, then we have to prove that this marginal pdf will be this much, okay. So here proof starts. Let us consider fxy be the joint PDF of independent random variables x and y. Okay, so to prove the above theorem, let us consider the transformation of xy to uv by u x plus y. It is given that u is transformed with the condition of x plus y. Okay, values of x will be addition with values of y. This is the condition that u is going to be transformed. Okay, so u is going to be considered. So u equal to x plus y, and here we have been considered that v equal to x. Here you can also consider v equal to y, no problem. Here we consider v equal to x, y I am going to tell to you, just wait. We considered, see here, if random variables are followed this relation, so obviously the values also has to be follow this relation. That means we can write u, values of u equal to values of x plus values of y equal to, here v equal to x, small v, values of random variable v equal to values of random variable x, v equal to x. So here if I'll be put instead of x v here, the y will be equal to u minus v. Now we are going to consider the Jacobian for the transformation. So here xy is going to be transformed to uv with the help of determinant of this one, del x by del u, del x by del v, del y by del u, del u y by del v. Here you can see del x by del u. Here u is the x plus, sorry, x is the v, x equal to v. So del x by del u obviously 0. Then del x by del v, del x by del v will be 1, and del y by del u, del y by del u will be 1, del y by del v will be minus 1. So here from this determinant we found Jacobian equal to minus 1. Thus joint PDF of random variables u and v will be how much? F of uv, function of uv equal to, as we just proved that this will be equal to given joint PDF of xy into modulus of Jacobian, that we are going to be consider over here. F of uv, which is the function of uv, equal to f of xy, function of xy into modulus of Jacobian, right? So this will be your what, joint PDF of random variable if x and y are not independent. Okay, here I written if not independent, then the value will be how much? Jacobian, modulus of Jacobian will be 1. So f of uv will be equal to fx y will be, sorry, f of uv or PDF of joint PDF of uv will be equal to joint PDF of xy, as Jacobian is 1 if not independent. So as in our theorem it has been given that x and y are independent, so here f of uv will be equal to f of x into f of y. That we know that if two random variables are independent with each other, then the joint PDF fx y can be written as fx x into fy y, multiplication of their corresponding marginal probability density function, that we know. Okay, so f uv equal to f of x, here instead of x we can write v, because we have been considered that x equal to v into f of instead of y we can write u minus v. So this represents the joint PDF of random variables u and v. Now we are going to go for the corresponding marginal probability density function or marginal density function, whatever you can write, marginal density function, or sometimes it is called as marginal probability density function of u will be fuu is how much? Minus infinity to plus infinity PDF probability density function into dv, that we know. Okay, that we know. You just recall that if PDF has been given this one and marginal probability density function is nothing but minus infinity to plus infinity f xy into dy. If independent, then this will be written as uh, fx x into fy y into dy minus infinity to infinity. That we know. So mgf of u will be minus infinity to infinity pdf of this one into dv. So it has been proved, right? But as it is independent, so we have to write instead of this one is nothing but this one. So we have to write f of u, or you can say that marginal density function of u equal to minus infinity plus infinity. This is nothing but this one. So this equal to into dv. Okay, it has been proved. Okay, proved. So here I am going to say to something to you that initially we have been considered that v equal to x, v equal to x, and in the question, or you can say in the theorem, it is already given that u we have to, or the u new variable has to be transformed with the help of this condition x plus y, and another v is going to be transformed. It is not given here. We have been considered v equal to x, but one can be consider that v equal to y, v equal to y. If we are going to consider v equal to y, then what is going to happen? You just watch here. It is given that u equal to xy, already given. Okay, u equal to xy already given. So u equal to xy. So here I considered v equal to y instead of v equal to x. So what we are going to get? So that implies x, v equal to y, you just put over here, v equal to y, x will be u minus v. So Jacobian is nothing but del x by del u, del x by del v, del y by del u, del y by del v. So del x by del u, del x by del u is nothing but 1, del x by del v, del x by del v equal to minus 1, then del y by del u, del y by del u, here u is not there, so 0, del y by del v will be 1. So here we found the Jacobian equal to 1. So if joint, now joint pdf of uv equal to joint pdf of xy into Jacobian, right? So as x and y are the independent, so it will be written as fxx fyy into 1. So joint pdf of u and v will be written as, here you can see, instead of fxx, it will be written as fx u minus v. Okay, and fy v. So here you can see this is the different as compared to this one. So whenever we are going to consider v equal to x, here you can see instead of a small y, this will be u minus v. But if we are going to consider v equal to y, then here fx will be u minus v, and f of fyv. Okay, and its corresponding fu will be equal to, and its corresponding fu will be equal to minus infinity to plus infinity, this much, fx u minus v into fy v into dv. Okay, so here is a somewhat difference we found. थोड़ा सा यहाँ पे जो चेंजेस है हमको दिख रहा है, यही है. अगर हम v इक्वल टू वाई लेंगे तो यहाँ पे u माइनस वी हो जाएगा. अगर हम यहाँ पे v इक्वल टू एक्स लेंगे तो यहाँ पे जो स्मॉल y था, यहाँ पे स्मॉल y, ये हो जाएगा u माइनस वी. ये थोड़ा सा चेंज हमको मिलेगा. ओके, सो यू हैव टू जस्ट focus yourself that what it has been given. What it has been given. Suppose you have to prove this one. Suppose in the question it has been given that you have to prove this one. So you just consider v equal to x, right? Suppose you have to prove this one, you just consider v equal to y. See, if I will consider v equal to y, here you can change, here the changes happens in the x, okay? But here हमने v equal to x जब लिया तो changes happens at y, okay? So you just remember this one. Now we are going to go for another theorem where u equal to xy. That means the variable x and y is going to be transformed to another variable u with the condition x into y. Okay, before that, here I am going to suggest to all of you that this theorem you can try in your rough. You can do it. Similarly, I written. Similarly, you can prove that if x and y are two independent continuous random variables, then marginal PDF of u equal to x minus y is given by this much. If x u, if y v minus u dv. So here you consider x equal to v. Okay, you just consider x equal to v, and you are going to get this answer. So if you are going to consider y equal to v, so you can get here here changes. You can found here the change will be appear here. Okay, so as you have to prove this one, you just consider x equal to v. Okay, so there is no problem. There is no problem that you are going to consider y equal to v. See, अगर आप x equal to v ले रहे हो तो ये मिलेगा. अगर y equal to v ले रहे हो तो यहाँ पे चेंज तुमको देखने को मिलेगा. तो अगर क्वेश्चन में ये दिया है यहाँ पे y में चेंजेस है तो v equal to x ले लेना. तो क्वेश्चन में यहाँ अगर चेंजेस है क्वेश्चन में, जैसे कि मैं इधर आपको बताया कि यहाँ पे चेंजेस आ रहा है, मतलब हमको v इक्वल टू वाई लेना है. तो यहाँ पे अगर चेंजेस आ रहा है v माइनस यू दे रखा है क्वेश्चन में, तो यू हैव टू कंसिडर y इक्वल टू v. बट इन द क्वेश्चन इट हैज बीन गिवन दैट this equal to this you have to prove. So I suggest that you have to consider x equal to v and prove it by yourself. Do by yourself. Next we are going to go for another theorem that u will be equal to x into y. We have to prove that marginal PDF will be this much, where u will be equal to x into y. That means the x and y will be transformed to u with the condition of x into y, right? So here we have to consider, let f x y be the joint PDF of independent random variables x and y. To prove above, same procedure we have been followed, and whenever you are going to do this one, you have to follow the same procedure here. Okay, whatever we done this one. So initially the same steps, that to prove above theorem, let us consider transformation of xy to uv by u equal to x into y and v equal to x. Okay, so as u is transformed with the multiplication of x and y random variables, so obviously the values of x and y, multiplication of values of x and y will be equal to u. So u equal to xy, small u equal to xy, and v equal to x, where y equal to, you can see that u by x and x taken as v, so u by v. So by considering this one, y equal to this one and x equal to v, y equal to v, u by v, and x equal to v, the Jacobian will be that is your del xy by del uv will be equal to del x by del u, del x by del v, del y by del u, del y by del v will be equal to 0, 1 by v. You can check. See, del x by del u is not there, 0. So like that, del y by del v del y by del v. So here u by v is there, u is the constant, so minus u by v square. So these two also you can found from here. So we found minus 1 by v is your Jacobian. Now the joint PDF of RVs, random variables u and v, will be written as FUV equal to joint PDF of XY already given, uh, into Jacobian. So this into Jacobian, modulus of Jacobian equal to 1 by v. This is nothing but if x and y are not independent. If x and y are not independent, this one. So if x and y independent, that means whatever given in the question, then this PDF probability density function will be f of x into f of y into 1 by v modulus, okay, or Jacobian modulus, you can say, to correspond the corresponding MGF, corresponding marginal density function, mg, you just df, you just write mgdf. So here also you have to change mgdf, marginal density function, okay. Just consider this is your mgdf, marginal density function, or sometimes it is called the marginal probability density function, will be how much, is equal to of u will be equal to minus infinity to plus infinity, this one, into 1 by v into dv, okay. So or we can write instead of same thing it has been written. So here instead of v we can write x modulus, right, because we have been considered that v equal to x, so dv equal to dx, so instead of dv we can write dx, right. So hence it has been proved, you can see, okay. Okay, so here we proved this one, and here also you can consider instead of v equal to x, v equal to y. So let's check that if you are going to consider v equal to x, then what you are going to get. See, instead of v equal to x, v equal to y, if I am going to take v equal to y, and here u equal to xy is there, u equal to xy is there. So obviously x will be equal to u by v. Here y equal to u by v. So here we found x equal to u by v. So x equal to u by v we found. So obviously here this will be instead of v, this will be u by v, and instead of u by v here we have to write what, uh, only v, because y is considered as v. And here Jacobian, how much we can get? We can get the Jacobian as, we have to just check what will be the Jacobian. Here you can see that del x by del u. Del x by del u means 1 by v. Del x by del v, that we can get minus u by v square. Del y by del u equal to 0. Del y by del v equal to 1. So here also we can found 1 by v is your Jacobian, okay. 1 by v equal to your Jacobian, but here we found minus 1 by v, right. But here v is considered as y, right. So at the end it will be mod y. So finally I can say that if we are going to consider v equal to y for this case, or v equal to y for this case, then f of u will be written as like this. F u will be minus infinity to plus infinity. F of x, this u will be u by v, and f of y, uh, y will be only v, okay. So here y has been taken as v, so dv equal to dy. So instead of dx it will be dv, right. Divided by, instead of x it will be mod y, right? Because Jacobian is 1 by v, so 1 by y it will be like this. So you just consider that what you have to prove. That means in the question what it has been given. So on the base of that question, you have to consider that what you have to take the v value. V value you are going to take x or you are going to take y. That you have to decide by considering the question before you have to prove. Okay. So another theorem is that you have to do by yourself, that if x and y two independent continuous random variables, then marginal PDF of u equal to x by y. That means xy transformed to u with the relation as x by y is given by this one, f of u equal to minus infinity to plus infinity f x v into f of y u by v into v by u square into dv. So here also you are going to consider v equal to x. V equal to x. If you are going to consider v equal to x, then you will be get this one. So likewise you can try that if you are going to consider v equal to y, then what will be the answer. Okay, as per the question, I suggest that you just take v equal to x and try to prove it. You can prove. Okay, so do this question by yourself. Okay, so here we have been discussed one and two, three theorems, and two theorems I given to you that you have to do by yourself. You can do it, no problem, very easy. You can do by yourself. These theorems are belongs to transformation of 2D random variable. Okay. Then in our next class, we are going to discuss few numericals based upon transformation of 2D random variables. Okay. So thank you so much for watching this video. Watch carefully, write down the note and ready for the next class. Okay. Thank you.